Welcome back. So today what we want to focus on is sections 2.1 and 6.1. And we're not doing the entire section, we're just pulling a couple pieces out of each one of them. In section 2.1, we're going to talk about function notation. We're going to start by defining a function and then talk about how we can come up with the value of a function. And then in section 6.1, we want to go over the classification of polynomials. Both things you should have, again, talked about in Algebra 1, but kind of a refresher so that we get into some more depth and more detail in Algebra 2, you remember what we're talking about. So what is a function? A function, the definition, is a relationship in which each element in the domain is paired with exactly one element in the range. You may have heard this a lot of different ways from your teacher. One way was, for every x, there's assigned only one y value. For every input, there's only one output, or it passes the vertical line test. All acceptable ways of thinking about it. The notation of a function is going to give you this f in parentheses x. We say this is the function f of x, and this is g of x. It's not f times x, it's not g times x, it's f of x. And what does that mean? F of x, it just means that it is a function. Whenever we see f of x, g of x, h of x, anything of x, tells us that that relationship is always going to hold. So if I gave you f of x equal to x plus 5, that tells us for anything that we put in for x, we're only going to get one y value out. So we can substitute that f of x with a y equals, and we probably more commonly see our equations as y equals x plus 5 instead of f of x equals x plus 5. The reason we do the function notation is to define it just a little better and saying, hey, this is a function that you should only get one value out for every x value that you put in. So some examples of some functions and non-functions. So we talked about the vertical line test. Vertical line test tells us that if we can draw a vertical line through anywhere on the graph and touch more than one point on the graph, it's not a function. So if we look over here, there's a lot of different ways that we can draw a vertical line and be able to touch more than one spot. There are places where it could only be one. So if I drew a vertical line over here, I would only touch it at one point. So I would say this is a function. But as I work my way to the right, notice here, if I drew a vertical line over here, now I can intersect it at 3 points. And that makes this not a function. So it doesn't matter if some places it passes. If it fails just at one place, it's not going to be a function. So we say that this is not a function. We can do this with a set of points. So if I draw a vertical line through all of these points, I can only touch one point at a time. So we say that this is a function. Now I might ask, or we could ask, could you plot a point on here to make it not a function? In that case, yes. All we had to do would be to put a point above or below any one of these points that are here. Say if I put a point there, that would make that not a function. Because I could draw a vertical line, touch 2 points, and I'm done. Down here, I can draw a vertical line and I can only touch 1 point at any given point in time. So we call this a function. And last but not least, we can come over here, we can draw a vertical line, we can touch it 2 places, so this one is not a function. And those are some examples of functions and not functions. So function notation, what is that going to look like? So if I give you an independent value, an x value, can you come up with the dependent value or the y value? So what does it mean? Well, we're going to give you a function, f of x equals x plus 5. Then it's going to ask you to find f of 2. Well, f of 2, notice we replace this x excuse me, with a 2. So that's what we're going to do over on the right side as well. We're going to replace that x with a 2. So 2 plus 5 gives us 7. So f of 2 is 7. So if you remember that f of x, we could write it as y equals x plus 5. When x equals 2, then our y value is 7. So this is really a coordinate. It's a point. It's the point 2, 7. Not that we have to write that, because this tells us f of 2 equals 7, our x value is 2, our y value is 7. So f of negative 1 tells us to replace the x with negative 1. Negative 1 plus 5 gives us 4. Now this is a kind of a fun one. This is really where Algebra 2 is going to play. F of a. Well, this tells us wherever we see an x, we're replacing it with a. So in this case, we're taking a plus 5. We can't do anything with that, so we're done. And we can do this with any kind of function that we want. So g of negative 1, I can plug in that negative 1. Negative 1 squared minus 5 times negative 1 plus 1. Negative 1 squared is 1. Negative 5 times negative 1 is positive 5 plus 1 gives us 7. G of 2, so we have 4 minus 10 plus 1, so we get negative 3. No, we don't. We get negative 5, don't we? Maybe somebody can't add today. Negative 5 it is. And then g of a plus 1. So I'm going to take my a plus 1 and plug it in. So I get a plus 1 squared minus 5 times a plus 1 plus 1. A plus 1 squared. Remember, a plus 1 squared is a plus 1 times a plus 1. If I distribute this out, like we did in Algebra 1, we'll get a squared plus 2a plus 1. Multiply your negative 5 through, we get negative 5a minus 5 plus 1. Go ahead and add like terms. We get a squared minus 3a, 1 plus 1 is 2, minus 5 gives us negative 3. And that gives us our answer for g of a plus 1. On to section 6.1 there, and classifying a function. So when we classify a function, we're going to classify it by degree and the number of terms. The first thing you want to make sure is that we put it into standard form. In standard form, we take the highest exponent first and work our way down. So here is an example of one that's in standard form. 3x to the 5th, 4x to the 3rd, minus 5x plus 2. Coefficients don't mean anything to us. The coefficient, remember, is the number in front of x. We're only looking at the exponents. We're going to start with the highest and work our way down to the lowest. The degree then is that highest exponent. So we'd say the degree of this polynomial is 5. Terms we separate by a plus or a minus sign. So if we come back up here to the example, we're going to have 1, 2, 3, 4 terms. The quick way of figuring out how many terms we have is count your plus signs or minus signs. We have 3 of them, add 1 to it, and we get 4. So what happens, how do we name them by degree? Well, if our degree, highest degree is 0, so the highest exponent is 0, we call that a constant. 3, 5, 7. So think of your numbers. Any number, all by itself, no variable, is called a constant. Degree of 1 would be a linear. The examples would be 2x. Remember, we can put a 1 for the exponent if there's nothing there. A 1, x to the first, or x to the first plus 1, and then 3x to the first minus 5. These are all linear terms because the highest exponent is 1. Degree of 2 is a quadratic. Notice our exponent, I forgot my exponent there. We have x squared, we have 3x squared minus 1, 2x squared minus 3, or plus 3. A cubic, oh no, we don't need that, do we? It was 3x squared plus 3x minus 1. A cubic is a 3 for our highest exponent. So here, 2x to the third plus 5. We have x to the third plus 2x squared plus 3x. Again, the highest exponent in that polynomial is 3. Quartic would be a degree of 4. So one big old nasty one, 4x to the fourth, 3x to the third, and so on and so forth. And a 5 degree is a quintic, where your highest exponent is 5. We can also do the number of terms. Number of terms, hopefully these names are familiar to you again, just to kind of review. One term is a monomial, so nothing, no plus or minus signs. 2 terms is a binomial, we'll have 1 plus or 1 minus sign. 3 terms is a trinomial, so we'll have 2 plus or minus signs. And then after that, we just kind of generically give them 4 term, 5 term, 6 term polynomials. So an example, we're going to classify by the degree and the number of terms. So remember, first we want to put it in standard form. How do we put it in standard form? We start with the highest exponent. In this case, our highest exponent is 1. We can go ahead and add those two together. So we have 6x minus 3. Can't combine those because we don't have common terms. So how do we classify this? Well, our degree is 1, so that gives us linear. And we have two terms, so it's a binomial. So we call this a linear binomial. I like to give the degree first and then how many terms, but either way would be acceptable. That's the way I was taught, so that's the way I do it. In this example, we can rewrite it. We write it as negative 3x to the fourth plus 4x squared plus 2x. So now we have the degree of 4, so it's a quartic. And we have 3 terms, so we call that a trinomial. And last but not least, our last example here, we can add the x to the fourths. So we have 3x to the fourth plus 3x to the third. Lots of 3's here. Plus 3x minus 1. Must have liked the 3's. So how do we classify this? Well, this is 4th degree. The 4th degree is a quartic again. We saw that above. But now we have 4 terms. So it's a quartic 4-term polynomial. And that allows us to talk amongst everybody on the number of terms and the highest degree or the degree of the polynomial. Enjoy!